Hey class, oops, let me pull my thing up. All right, so this is a quick video that derives the formula vector u dot vector v over length of u times, it's not dotted there, these are just, lengths are just real numbers, equals the cosine of theta. And in class I mentioned that this comes from the law of cosines. So I put the law of cosines up here. So if you have a triangle where you have ABC as the lengths of your sides and theta is the angle between A and B, then the law of cosines says that a squared plus b squared minus 2ab cosine of theta is equal to c squared. So what we're going to do to go from this, to here is we're going to put this triangle up here, we're going to put it on a grid and then write down those lengths and these points as vectors and standard positions. And then from there, we'll do the math. So what I'm going to do is I'm going to call this point is x sub b comma y sub b. And this point I'm going to call x sub a comma y sub a. And if I think of them as vectors, then I can think of x a y a is one vector and xb yb as another vector. Okay, we're going to use these points to work things out. So in the way we've set it up now, then the length of, so a is just the distance from this origin up to xa, ya, up to that point, and b is the length. So a and b aren't vectors; they're the length of those lines, or the length of those vectors. So, so we have to translate the a's and b's up in the law of cosines to what they mean in terms of x's and y's. So a squared, so that's the length of a squared. The length of this thing is a, and so to get that length we could take a is the square root of xa squared plus ya squared, and b is the square root of xb squared plus yb squared. And the reason that is because if I take the x component and the y component, this distance here is x sub b, this distance here is y sub b, this distance here is x sub a, this distance here is y sub a. So we're just using the Pythagorean theorem here to find those lengths. And so a squared, well, let's do c squared while we're at it. C squared is this distance here. Doesn't happen to be horizontal. I happen to draw it horizontal, so we're not going to assume that. So that's the distance between 2 points. So we just use the distance formula. So c is the square root of xa minus xb squared plus ya minus yb quantity squared. So those are all of our lengths, and now we're going to plug those in to the law of sines. So we get the square root of xa minus xb quantity squared plus ya minus yb quantity squared all squared. So this is c squared right there. So you can see that I'm using the left-hand side up there, that equation equals it equals a squared. So that's the square root of xa plus ya both squared, and then plus b squared. Oh, that's a, but I need to square that. And then b is xb squared plus yb squared. Square root, and then we're going to square it because it says we have a squared plus b squared on the right hand side minus 2ab, so minus 2 times the square root of xa plus ya, both of those squared, times the square root of x squared b plus y b squared, and times cosine of theta. All right, now let's simplify some things and see where that gets us. Here the square roots, here the square root and the squared will cancel out, square root and squared, square root and squared. So we can start writing those out. So x, just get xa minus xb quantity squared plus ya minus yb quantity squared equals xa squared plus ya squared plus xb squared plus yb squared minus 2x squared a plus ya squared, and another square root, xb squared plus yb squared times cosine of theta. And if I expand out this left-hand side, if I expand out this side, then I should have some things that cancel out. So this is xa squared xa squared minus 2xa xb plus xb squared plus ya squared minus 2 yb plus yb squared equals, and I'm going to save us some time, and notice this xa squared here cancels out with the xa squared there, the ya squared here cancels out with that one, xb squared cancels out with that one. Okay, got them added to both sides. Let's just get rid of those. So, and all I'm left then with on the left hand side is a minus 2 square root of x squared a plus y squared a square root of x b squared plus y b squared times the cosine of theta. And rewriting the stuff on the left, I have a minus 2. I'm going to pull out a minus 2. I've got a minus 2 here and a minus 2 there. So a minus 2 xa xb plus yb. Now, right now you should notice that this meaning this expression right here is the dot product of these two vectors. So if you dot those, we get xa times xb plus ya times yb. So so we have that expression. That's good because we want to end up with a dot product over here. So where u and v in this case are u in our case is one vector, v is the other vector. So minus 2 square root of x squared a, just rewriting here. So we've got a minus 2 on both sides. Divide that out. Now this, we just talked about, is the product of xa and xb. Of those two things. If we call them u and v respectively, then we could just rewrite that as u dot v. And this, they are just the lengths of u and v. Right? A is the length of u and v, b is the length of u and v. So, or a is the length of u, b is the length of v. So, so that we could just rewrite as u. This we can rewrite as the norm of v. So norm of u, really. And times cosine of theta. And then you just divide both sides by this. And we're there. So then we just get cosine on the one side and this expression on the other. Okay, there we go.